Astronomers using the new Daniel K. Inouye Solar Telescope in Hawaii have released their first public images of the Sun, and they are the most detailed images of our parent star ever taken. Images from the Next Generation National Science Foundation (NSF) Solar Observatory reveal details on the surface measuring just 30 kilometers, 18 miles in diameter. The new 4-meter, 157-inch instrument, the largest solar telescope in the world, recorded images and video of turbulent plasma on the surface of the Sun, providing an unprecedented level of detail for solar researchers. The Daniel K. Inouye Solar Telescope in Hawaii gives astronomers an unprecedented look at our parent star. Image credit, ENSO/ENSF. Since ENSF began work on this ground-based telescope, we have eagerly awaited the first images. ENSF's Inouye Solar Telescope will be able to map the magnetic fields within the Sun's corona, where solar eruptions occur that can impact life on Earth. This telescope will improve our understanding of what drives space weather and ultimately help forecasters better predict solar storms, said Franz Cordova, ENSF director. Read, this new satellite is dedicated to observing alien worlds outside of our solar system. The solar weather report: the Sun converts 5 million tons of hydrogen fuel into energy every second, and that energy is driven, over the course of hundreds of thousands of years, from the core of the Sun to the surface. 8 minutes later, a small portion of that energy lands on Earth, driving terrestrial weather, affecting the chemistry of the world, and driving nearly all life on the planet. Each individual cell seen in the video carrying heat from the inside of the Sun to the surface is roughly the size of Texas. Hot solar plasma rises from below the bright center of these cells, before it cools and falls back into the Sun, producing the dark edges of the cells seen in the video. Our understanding of how the Sun operates and how conditions there affect our own world has evolved over time. During the 1950s, astronomers discovered the solar wind, which permeates the solar system. Later research revealed a tenuous outer solar atmosphere extends beyond the orbit of the Earth. Space weather, driven by solar activity, can affect conditions on Earth. Magnetic forces produced by the Sun can form solar storms, disrupting air travel, disturbing GPS and cellular communications, and impacting electrical systems. As human society becomes ever more dependent on technology, understanding space weather grows increasingly critical for civilization. Hot, energetic plasma traces outlines dictated by the immense magnetic field of the Sun. Image credit, ENSO/ENSF. On Earth, we can predict if it is going to rain pretty much anywhere in the world very accurately, and space weather just isn't either yet. Our predictions lag behind terrestrial weather by 50 years, if not more. What we need is to grasp the underlying physics behind space weather, and this starts at the. You can read full post on cryptophans. News, link available in text below.